Alright everybody, this is section 7.1. This is called the law of sines. This is going to be a tool that we use to solve triangles. Now it doesn't necessarily have to be right triangles like we have used in previous chapters or anything like that. There are relationships that does not necessarily need SOHCAHTOA to solve. Okay, so what we're going to do is we're going to use what we call the law of sines. What is the law of sines? It can be any mixture of these formulas that you see here on this page. Okay, now you do not need all three of them to solve each particular problem. Okay, so what we're going to do is we're going to basically take like two of them, and that's what you're going to set up a proportion. Okay, so the sine of an angle divided by its side that's across from it, so the one that's related to, is equal to any other sine of the angle divided by the side corresponding with that angle. Okay, and these things can be flip-flopped. Just be consistent. So if you have the sides on the bottom, make sure the sides are on the bottom. If you have the sides on the top, that's fine too. It doesn't matter how it works, however you want to set it up. There's going to be no consistency of how I do it, so it's just going to be kind of a mixture of everything. So excuse me, how does this work? Given two angles and one side, it says to solve the triangle. So just to recap, when you solve a triangle, you need to have every angle and every side accounted for. So in this particular case, I now have two angles, and that instantly should allow you guys to understand or figure out what the missing angle C has to be. Okay? Remember, a triangle has to add up to 180, and I already have two sides. So if I subtract 30 and subtract 70 in that order, or any order, doesn't matter, just subtract them from it, you should end up seeing that your remaining angle C, okay, big C, capital C, is equal to 80 degrees, okay, because these guys should add up to 180. 30, 80, and 70 should add up to 180, all right? So just make sure or know that, so I know that this angle right here is 80 degrees. And what I really want you guys to do on your paper is box your answers so I have a clue, because it's going to get messy. It's going to be a lot of material happening. Okay? Then, once you have all your angles set up, you can find the missing sides. It's pretty quick and easy. What I want you guys to focus in on what was given. Is there an angle and is there a side corresponding to it in which I gave you both pieces of information? That's going to be your hitch pin. You guys need to find that. So in this case, I'm given side and angle B. So I'm going to use the formula of sine B over B, and I'm going to find side A equal to sine of angle A over little a. And if I plug this into my formula, I know that sine of angle B is 30 degrees divided by side B, it's 8 centimeters, is equal to, and if I want to find side A, because that's one angle that I found, I could say is equal to sine of 70 degrees over A. And now all you need to do is cross multiply. Okay? And it becomes quick and easy. So I know that. I'm just going to go right up here. A times sine of 30 equals 8 times sine of 70. And now's where you need your calculator. Okay? You guys are going to need to make sure your calculator's in degree mode. Alright, that's a big situation. And then all you got to do is solve for A. So divide by sine of 30. And then A equals, in your calculator, go 8 times sine of 70. I'd push equals, then divide by sine of 30. As long as you're in degree mode, A should equal 15. And then you got to label it since it was centimeters over here. I know A is 15 centimeters. I like boxing it here. That way I know what my answer is after all this craziness happens. This is 15 centimeters. Now, should it be almost twice as big? Actually, it's more than twice as big. Okay, getting there almost. Okay, so make sure that it is longer. Just kind of a quick check. All right, side C. Side C should be longer than side A because angle C is 80, the biggest angle. But how do I go about finding it? Once again, you're going to set up the law of sines like you did. Once again, I want you to go back. What was given in the problem? The B's were given. So I once again would do that. I need to find side C. So I'm going to say that side C over sine of angle C is 80. I'm mixing it up. It doesn't matter what order you do this in. Since I started with the side, I was given both the b's. So I'm going to say side b is 8 over angle b sine of 30. Once again, you can simply just cross multiply. So I'm going to do that. I'll switch colors here. And I would get c times sine of 30 equals 8 times sine of 80. And now how do I solve for my side c? I simply have to divide by sine of 30. And then c equals 8 times sine of 80 divided by the sine of 30, and end up getting 16 centimeters, because I believe said round to the nearest whole number on these things, so that's why I'm rounding to that. Your calculator might show differently, and that's 16 centimeters. And once I have all of my answers boxed here, I usually like to throw them on the diagram and see if they make sense. So in this case, the largest angle goes with the largest side, smallest angle, smallest side, middle, and middle. I can feel confident that that's what my answer is. Okay, so that's just a quick showing you how the law of sines works. So here's kind of a picture that I grabbed off the internet. Find the distance the shot put was thrown off this picture. So if you kind of look at the diagram, it shows that we're 562 feet from the observation booth, or the press box, whatever way you want to think about it. Okay, we don't know this distance at all, but I know that the angle from the dude in the press box looking in at the shot put is 5.7 degrees. Okay, and I know that it's 85.3 degrees down here for whatever reason. I know this. Okay, and I want to know how far the shot putter threw the shot put. Okay, so that's what I'm looking for. So in this particular scenario, do you have an angle that is across from the particular corresponding side? If you have that, you can do the law of sines instantaneously. So since I have that, I can do this. So I'm going to say that the sine of my angle down there on the bottom, 85.3 degrees, okay, over that side length, okay, so that's the corresponding ones, is equal to any other side with any other angle that I'm dealing with. So since the side I'm looking for has an angle there, I just got to put the angle on top because that's what I started with. Once again, there is no rhyme or reason why I put the angle on top or the bottom. That's simply a personal preference. And then you just have to cross multiply. So I'm going to go x times sine of 85.3 degrees equals, go the other way, 562 times sine of 5.7 degrees. Alright, and to solve for x, I literally just need to divide by the sine of 85.3. So x equals, and if you do all this handy-dandy stuff in your calculator with the calculator in degree mode, once again, remember, it'd be 56.006 off your calculator, which it says round to the nearest tenth of a foot. Since I don't really have a tenths or a hundredths place, I can round it to exactly 56 feet flat. Alright, so that's how far that shot putter threw the shot put. And that's just a simple another example of how you use the law of sines. Okay, here's the last one, a little more difficult. It's a more or less trying to understand how this works, and I'll kind of explain this to you. But let's say a traffic light that weighs 22 pounds is suspended by 2 wires is shown. So basically we have 2 wires holding down this traffic light off the pole up on the top. Alright, and it says find the magnitude of the tension of the wires AB and AC. So basically we want to find the tension in this wire and the tension in that wire as they go. So we label them T1 and T2 already. There are some angles in here that have already been shown. And then it just goes into a little bit of physics that just said if the light's not moving, technically then the state of static equilibrium, blah, 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 blah. Basically, long story short is this side straight up and down, the weight, all right, how heavy is the thing? It's 22 pounds. So technically, if you had the wire going straight up and down, there'd be 22 pounds there. So we can just kind of throw an idea that this is 22 pounds regardless, okay? And what we can do, since this thing is technically static equilibrium, we can adjust this side and we can kind of make it come this way. Kind of like a parallel line. It's the same torque that would be there, so we're just going to pick it up, pretend that it's not actually hanging, move it, and it's going to be the same torque, and we can extend this guy up. Okay, and what I end up doing is you can build a brand new diagram. So what I'm going to do is just take basically the right half of what we're doing. So instead of kind of going both ways, I'm going to make one triangle here. Okay, and what we know is that the weight is 22. That would be this side right here. Maybe if I get fancy with some colors. This side is 22 pounds. That's the weight going down on it. All right. And what we need to try to figure out is what are all the angles. So actually I've already done this here. So this angle is 60 degrees. Okay, we already know that this angle is 75. I dumped that in there. And this one's 45 because these guys are going to be alternate interior angles. And that's what's going to be left over is 75. That's how I can find those angles so quickly. And now all we got to do is find your T1 and T2. So this is still torque 1. This is how much torque's 2. And you can just use law of sines twice. Okay? So we have this side corresponding with the 75 degrees. Since I have both of those, this becomes quite simple. So I'm going to say the sine of 75 degrees over its corresponding side of 22, which is the weight, is equal to, let's find T1 first. So what's that related to? The 45 degrees up here. So sine of 45 degrees over T1. And now you guys just do your cross multiplication. Okay? So I cross multiply, and I get T1 times sine of 75 equals 22 times the sine of 45. And now you divide the sine of 75 over and do your math, and T1 is going to end up equaling 16.1 pounds. Okay? And then likewise, you do the exact same scenario. You still have the 22 and the 75 as the stuff that's given to you. I'm just going to flip it around and just show you that it doesn't matter which way you do your angles and your sides. Once again, just make sure you're consistent with it. Alright? I want to look for T2, so this time T2's on top because my side was on top. Over, what's the angle across from T2? It's 60 degrees, so I'm going to go sine of 60 degrees. And once again, you just have to cross multiply. So T2 sine of 75 is equal to 22 sine of 60 degrees. And once again, just divide your sine of 75 over. And if you do that on your calculator, 22 times sine of 60 divided by sine of 75, you get 19.7 pounds. Okay, so if you go back up to your actual physical diagram, you're going to end up seeing that there's 19 pounds of torque on that one, and there's 16.1 pounds of torque on that wire. Okay, and that's how we go about doing the law of sines. Here's the assignment that we're going to be working on in class tomorrow, and I hope you all have a wonderful day.